Okay, this is a note taking, all of it. It's just kind of a recap of what we've done. We're pretty much at the end of the material. So your job's to do the operation on all these. So here the operation is a plus. There's no time, so I don't need to mess around over here, draw rainbows, any of that stuff. So I start drawing my blank. So what's the highest power x is to? Second, first, nothing. Second, first, nothing. So blank x second plus blank x plus blank. I better get myself a calculator here. Oh, sorry about that. Okay, so x second, I've got 8 and negative 11. So I want to add those. 8 plus negative 11. I think it's negative 3, and indeed. Okay, now x, regular x, I've got negative 3x, positive 2x. So I've got negative 3 plus 2, negative 1. Okay, and then the constants. I have negative 10, negative 7. Remember, the minuses make it negative. Negative 10 plus negative 7, negative 17. Okay, that's my answer. Okay, number 2. This time we have 2 parentheses. There's no sign between them, so that is a multiplication. So we got to get some rainbows going. And also in multiplication, I need my x's to have numbers in front. So we have a 3, and that would be a 1. Okay, so I circle the 3x. I'm going to distribute 3 to 1x and 3 to 5. So I write 3x, 3x, and I'm multiplying it by 1x, and I'm multiplying it by 5. Then we have negative 7. Negative 7 to 1x, negative 7 to 5. So negative 7 then is a factor twice, and it's by the same two things, 1x, 5. Okay, now before I multiply, I got to make sure all my x's actually have powers on them. So this x here would be a 1 power. That'd be a 1 power. That'd be a 1 power. We don't have anything there, so don't put a 1 there. Nothing here, and then 1, and then nothing at all between these two. So 3 times 1 is 3. Now on x, I got 1 plus 1, which is 3x a second. 3 times 5 is 15. Then on x, we just got the 1. Nothing to add to it. Negative 7 times 1 is negative 7. Then on x, we just have the 1. Negative 7 times 5 is negative 35. Okay, so we have sum of powers that are second, first, and nothing. So these are like terms. Okay, so we're going to draw out our blanks. X second is the highest. So blank x second plus blank x plus blank. So x second has a 3. Easy enough. Now x, we need to add the 15 to the negative 7. So 15 plus negative 7 is 8. Negative 35. Okay, number 3. This again, there's no sign, so that's a multiplication. Now make sure all the x's are covered. That's 5, that's 2, that's negative 3, and then that's 5. Okay, so we're just going to distribute this 5 here. So 5 to 2, 5 to negative 3, 5 to 5, 5 to negative 1. Now I just drew 4 rainbows. So we're going to write 5x to the 4th, 5x to the 4th, 5x to the 4th, and 5x to the 4th. And I'm multiplying by 2x to the 3rd, then negative 3x to the 2nd, then positive 5x, and then negative 1. Okay, we've got to figure out these products. Okay, so that's 4 and 3, 4 and 2, 4 and that one would get a 1, and then 4 and nothing. Nothing goes with that 1. 5 times 2 is 10, and on x I've got 4 plus 3, which is 7. 10x is 7. 5 times negative 3 is negative 15. Then on x we have 4 plus 2. That would be 6. 5 times 5 is 25. And x, you got 4 plus 1, and that's going to be 4 plus 1 is 5. Then on the at the end, you got 5 times negative 1 is negative 5. And then x here, you just have the 4, nothing to add. Now look at all your powers, x7, x6, x5th, x4th. They're all different, so you don't need to draw the spaces out, okay? The blanks are really only useful off of this if you have some powers that are identical, that are the same. Here they're all different, okay? 7, 6, 5, 4. So I just write them all out with pluses between them. So 10x to the 7th plus negative 15x to the 6th plus 25x to the 5th plus negative 5x to the 4th. That's my answer. Again, you don't need to draw out spaces if all the powers are different. Okay, number 4. Now remember, when I have a power of 2 and then inside that parentheses you see a plus, all you do is get rid of the power and duplicate the plus, okay, and write the same thing. So we have a multiplication problem. We got to make sure then all the x's have numbers in front. So we're going to put 1 and 1. Okay, now I start my rainbows. Okay, so I've got 1 to 1x, 1 to 10. So 1x has 2 rainbows coming from it, springing out from it. And we're going to multiply by 1x, and we're going to multiply by 10. That takes care of that. Then I have the positive 10, so I need to distribute positive 10 to 1x and positive 10 to 10. So 10, 10. And then again, I multiply by the same 2 factors. Okay. Okay, x, we got 1, 1, 1 and nothing, nothing and 1 and nothing. So 1 times 1 is 1. Then on x, you got 1 plus 1, and that's 2. 1 times 10 is 10. Then on x, you have a 1. 10 times 1 is 10. Then on x, you have a 1. And 10 times 10 is 100. Okay, now on this one, I've got a second power, a first power, and nothing. So I have identical powers here. Okay, so I want to draw out my spaces. X second's the highest. So blank x a second plus blank x plus blank. So we got 1 on the x to the second. 10 plus 10 is 20. And then we have 100. Okay, next page. Okay, first off, again, make sure all your x's are covered. 1, and then nothing else. Okay, this time I don't draw any rainbows. I'm not going to do anything over here because I have a subtraction operation. Okay, so I draw my blanks right away. So I've got x second, nothing, x third, x. X third, x second, nothing. So x third's the highest. So I go blank x to the third plus blank x to the second plus blank x plus blank. Don't need to mess around over there. Just know you're not multiplying. X third, go find them. We have a 4x to the third, kind of tricked me there. And then a 7x to the third. Now remember, we're subtracting, not adding. So I take positive 4 and subtract 7. Gives me negative 3. And those are gone. Now x second, you've got 1x second and negative 3x second. Okay, so we got 1 minus negative 3. 4. Cross those out. Okay, then regular x, you got a 5 positive, and that's it, okay? So what I technically do is it's 5 minus 0, okay? It's 5. Okay, we can cross that one out. And then for my constants, I have a negative 8 minus, and then a positive 5. So I will be taking negative 8 minus 5, negative 13. Okay, that's all there is to it if there's a plus or minus, so there's no multiplication. Now here we'd have multiplication right here. So I'm going to be working over here with my rainbows. So x, I'd have 1, 1, and that already has a 4. Okay, so circle the first thing. and we distribute 1 to 1, 1 to 4, 1 to 2. I just did 3 rainbows, so I write 1x down 3 times. Okay, then it's going to be 1x to the second, 4x, and 2. Okay, then positive 7. So 7, 7, 7. Then 1x to the second, 4x, and 2. Okay, then the x's, you got 1 and 2, 1, 1, 1 and nothing, nothing and 2, nothing and 1, and nothing at all. Okay, so we got 6 products to find. These problems, I don't like these. I hate these. These are the worst. 1 times 1 is 1. Then on x, it's going to be 1 plus 2 this time, and that's x to the third. 1 times 4 is 4. Then on x, it would be 1 plus 1, and that's x to the second. So far, they're both different. 1 times 2 is 2. Then on x, we just have the 1. We don't add it to anything. So I got 3, 2, 1. So far, they're all different. 7 times 1 is 7. X, we just have the 2. We don't add to it. There's nothing else there. And 7 times 4 is 28. Then on the x, it's just a 1. Don't add to it. And 7 times 2 is 14. Now, we did end up with some powers that were the same. 3, 2, 1, and then another 2, another 1. So I need to draw out my blanks here, okay? Third power is the highest. So blank x to the third plus blank x to the second plus blank x plus blank. X third, we have 1. X second, we have the 4, x second, and the 7, and we add those. 4 plus 7 is 11, okay? Now for x, that means x to the first, so I have the 2x to the first and the 28x to the first. 2 plus 28 is 30. Then 14. And that's it. As soon as those blanks are filled out, we're good. But remember, if there's no, again, without a times, you don't need the rainbows. Okay, number 7. We got a parentheses with 3x plus 2 the second. Now again, I know with powers, you're used to making them boxes, but not when I have a plus in the exponent, okay? A plus or minus needs to be duplicated. So I circle that, and then it's times, and then we got 3x plus 2. Now, we want to do our rainbows because we have multiplication. So I circle the very first one, and I go 3 to 3x, 3 to 2. So 3x, 3x. And we'll be taking it times the other 3x and the 2. Now there's another one. There's a 2. So I take 2 to 3x, 2 to 2. Okay, on the x's, we got 1, 1, 1 and nothing, nothing and 1 and then nothing. So 3 times 3 is 9. Then on x, we got 1 plus 1, and that's 2. 3 times 2 is 6, and it's just x to the 1. 2 times 3 is 6. We got x to the 1. 2 times 2 is 4. Okay, you got 2 powers that are the same right here. So we want to make our blanks. So x second, so blank x second plus blank x plus blank. So x to the second, you just have the 9. Okay, for regular x, you're looking for these, and you cross out the 9 once you write it. You got 2 first power, okay? So we need to add 6 plus 6. That's 12, and then 4. Okay, number 8. Again, this means multiplication if you don't see an operation sign. So you need to draw rainbows. So you circle just that, and it's 3 to 4, 3 to negative 3, 3 to 5, and 3 to negative 3. So that, I just drew 4 rainbows from that. So I write 3x to the second 4 different times. Okay, and I just take it times 4x to the third, negative 3x to the second, positive 5x, and negative 3. Okay, now there ain't really anything else to do rainbows with because that's the only thing I had outside there, so I go ahead and onto this. So 3 times 4 is 12. Remember, you don't draw rainbows into the same parentheses. A lot of people would go to this and start drawing rainbows. No, this is in the same. Never draw a rainbow from the same parentheses, ever, within the same parentheses. Okay, and then I have 2 plus 3. We know that's 5. 12x to the 5th. 3 times negative 3 is negative 9. Then on x, you get 2 plus 2, and that's 4. 3 times 5 is 15. Okay, and then you have x, and then 2 plus 1, that's 3. And then 3 times negative 3 is negative 9 on x is to the second. Okay, now those are all different powers, 5, 4, 3, 2, so I don't need to draw the spaces. Okay, I just write them down. 12x to the 5th plus negative 9x to the 4th plus 15x to the 3rd plus negative 9x to the 2nd, and we're good. Okay, once again, with these problems, if you have a minus or plus, you don't need to do anything here because there's no multiplication. Now here there is multiplication, got to do it. Multiplication, got to do it. Multiplication, but it's just this term here that gets distributed. Okay, now a couple of story problems here. They're kind of the same. Not really sure why there's two. I want to do them both so people don't think I'm assigning anything today. Okay, you plan to build a walkway that surrounds a rectangular garden as shown. The width of the walkway around the garden is the same on every side. The dimensions of the garden are 10 by 9 feet. So in this picture, we put 10, 9. And somebody asked yesterday, well, how do I know what goes where? Well, I normally put the first number on right here and the second number here, but it really doesn't matter the order. Okay, so I see that that's been measured out from here to here, and then look straight up, you got 10, and then the edges, I don't know how wide those are, so x, x. And it's the same deal with the width. From here to here, you look straight across, you got 9, edges, don't know, x, x. Okay, so now that I have that, I can write a polynomial that represents the area of the garden and the walkway that surrounds the garden. So I make parentheses, it's going to be multiplication. And this is length, this is width. Don't put those in big numbers. So the length, I have 2 x's here first. So 2 x's, and then we want a plus 10. You want to put the x's first and then the one number behind it. And then I got 2 x's here with a 9. So it's going to be 2x plus 9. Okay, we're multiplying, so we better start drawing rainbows. So here's my first term. Remember, never go in the same parentheses. 2x, 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 9. So 2x is written down twice. Then I times 2x, and I times 9. Then we can get rid of that. Then positive 10, 2x and 9. So 10, 10, 2x, 9. Same two terms. My x is 1, 1, 1 and nothing, nothing and 1, and then nothing at all. 2 times 2 is 4. Then on the x, 1 plus 1 is 2. I guess you can write 1 plus 1. It's 2, though. 2 times 9 is 18. You got x. It'd be just to the 1. 10 times 2 is 20. That'd be just x to the 1, and that'd be 90. Okay, now we got some powers that are the same here. 1, 1, 2, 1, 1, nothing. So there is a repeat of the power. So we want to draw our blanks to organize the work. So blank x to the second plus blank x plus blank. So x to the second, we got 4. X, 18 plus 20 is 38. And then we have our 90, okay? And that's been simplified. Now part B, find the combined area, the width of the walk, if the width, that should say if the width of the walkway is 5 feet. So that means these, what it's telling me is that these x's are 5s. Okay. Now we're going to go parenthesize them here, and then we're going to write this with the parentheses. So I've got a 4 parentheses, now that parentheses is to the second power, plus 38. and then a parentheses. That's not to any power, to the first power, but don't put that down. That'd be stupid. Plus 90. Okay, and we're going to slip 5 inside of each parentheses. Okay, so I have 4 parentheses 5 the second plus 38 parentheses 5 plus 90. Okay, I got 380. Okay, it'd be 380 square feet, but I don't really worry too much about the labels when I do these. Okay, the dimensions of a maze are 12 feet by 10 feet. The walkway around the maze is the same on every side. So again, we can put 12 and 10, just like that. And then measure the whole thing just from start to finish, and then mark where the centerpiece starts and finishes. So from the middle we have 12, and then X, X. And then I measure the width where the centerpiece would start and stop. Okay, so from here to here is 10, then we got X, X. Okay, creating an area. Okay, and anytime I see area in a shape, we set up length times width. Okay, this is a rectangle again. Now, I know that one day we did some triangles, but generally I don't really put those other than that one day. So length, width. Length is around the bottom, so there are 2 x's with a 12, so it's 2x plus 12. Then the width would be a 10, and then the 2 outside x's, so it's going to be 2x plus 10. Okay, it's multiplication procedure, so we're going to circle the 2x, and then distribute it to 2x, and distribute it to 10. So 2x, 2x, times 2x, times 10. Well, that takes care of that guy. Then 12, 12, 12. And then 2x and 10. Okay, 1, 1, 1. 1, nothing. 2 times 2 is 4. And then x, 1 plus 1 is 2. 2 times 10 is 20. And x would just be to the 1. 12 times 2 is 24. X just be to the 1. 12 times 10 is 120. Okay, now I got 2 identical powers here, so we need to make our spaces. So blank x second plus blank x plus blank. So I got 4, and then x, so 20 plus 24 is 44. Then I have my 120. Okay, so now it says find the combined area if the width of the walkway is 1 foot. So that's telling me that these x's are now 1s. Okay, those are going in for the x variable. So replace the x with parentheses. So I have 4. I have a parentheses that would be to the second power plus 44, and then a parentheses, no, not to any power there, plus 120. And we're going to put 1s in each parentheses. So I can find out what this equals on my calculator. So I have 4 parentheses. We're going to put 1 in for x, close it, second power. Remember the second power key's right here, okay? Plus 44, parentheses 1 without a power there, and then plus 120. Okay, and that gives me 168. That's actually the same problem you did on your own yesterday. Okay, all right, that's all I have to say on that. That's pretty much what your test next late. It's either Tuesday or Wednesday we'll take it, looks like. Okay, not real exciting stuff, but I think you guys have gotten it.